NPR. So here's the last example of this branch of permutations. How many ways are there to find the top 5 GPAs in a class of 40 students? And we're assuming that ranking matters this time. For, like, I don't know, maybe a prize or the length of a speech you can give at graduation or something like that. Either way, we are choosing from a group of 40 and we're choosing 5. So this is 40, pick 5. So I start my formula by writing 40 factorial, 40 minus 5 all factorial, and this gets me 40 factorial over 35 factorial, which probably doesn't really help you. So let's use the memory trick. The memory trick of we're taking 40 factorial but just writing the first 5 numbers of it. So this would be 40 times 39 times 38 times 37 times 36. And you can see we stopped just before we hit the number 35. Just like in the example of the Olympic swimming meet, we stopped just before we hit the number 5 because 5 is 8 minus 3, the number of people we're picking from minus the number of people we're picking. And then in the example of the raffle, we wrote 12 times 11 times 10 times 9, stopping just before 8, which ended up being 12 minus 4. So anyway, here's the multiplication we have to do. I will go ahead and work this out in my calculator right now. Gives us a total of 78,960,960 different ways to find the top 5 GPAs in a class of 40 students. So finally, we come to the third idea within permutations, and that's the idea of ordering a whole bunch of items when you know that there are actually some duplicates within that set of items. So the first example I give is a bag of 7 airheads, where we get 3 grape, 2 watermelon, and 2 blue raspberry. And we're trying to figure out in how many orders we can eat them, assuming that all the grape ones are exactly the same, all the watermelon ones are exactly the same, and both of the blue raspberry ones are exactly the same. Now, there is a formula that we use for this. It's right here. If we have a certain number of items and we have some duplicates within that, and this could apply to 3 duplicates, 4 duplicates, and so on, we take the factorial of the number of items and we divide it by whatever we get by multiplying the factorials of our duplicates. So I have 2 examples for this that we'll quickly use to go over this. First, we have 7 airheads in the bag. So I will start by finding 7 factorial. And we will divide this by, I have 3 grape. So that means that in my denominator of this fraction, I'm going to put 3 factorial. 2 watermelon means I'm going to multiply this by 2 factorial. And 2 blue raspberry means I'm once again going to multiply by 2 factorial. So we're just looking for the numbers of our duplicate items that we see. And we can have the same number more than once. That is completely okay, completely legal. Now, our only goal is to just go ahead and figure this out. 7 factorial is 5,040. 3 factorial times 2 factorial times 2 factorial is going to be the same as 6 times 2 times 2, which is 24. And 5,040 divided by 24 is 210. So in a bag of 7 airheads, where we have 3 of one flavor, 2 of another flavor, and 2 of a third flavor, there's 210 ways to eat them. Now the second example is a little more boring. It's just thinking about how many ways there are to arrange or rearrange the letters in a certain word. In this case, the word that I chose is the word letter. Very stupid, but it's still a good example. We have 1, 2, 3, 4, 5, 6 letters, which means my formula is going to start with 6 factorial, and we are dividing this by any duplicates that I see. For instance, I see 2 T's. So 2 factorial will go in my denominator, and I see 2 E's. So another 2 factorial will go in my denominator. This 2 factorial was for the T's, this 2 factorial was for the E's. When it comes to L and R, those are both singles. We could write 1 factorial, but 1 factorial is just 1, so that's really not necessary. And in a way, whenever you take a regular factorial, you kind of do that. You kind of divide by 1 factorial a bunch of times, but since it's 1 every time, it doesn't matter, and we don't need to write it. So anyway, 6 factorial equals 720. That's the numerator of our fraction. Now for my denominator, 2 factorial is 2. 2 factorial is 2 again, and 2 times 2 is 4, which means my answer for how many arrangements there are for the letters in the word letter is going to be equal to 720 divided by 4, also known as 180 orders. So that was the other example of duplicate items. I did also want to go over very quickly how to find these factorials in the calculator. So here's my calculator. The most important button here is this one, the math button. Because if I press the math button, you can see that now I'm in this screen with a few different menus. The menu just to the left of where I start is the probability menu. And you can see I have NPR and factorial here, but I can't use those just yet. The calculator makes me type a number in before I can do either of those. So I will press second and quit to get out of that. Now that first problem with adopting the puppies, I needed to find 4 factorial. So I would type 4, press the math button, probability menu, exclamation point, and that gave me 24, which is what I was expecting. Second problem had me find 6 factorial, so there's 6, math, probability, exclamation point that it'll read as factorial, and I got 720. Same as when I worked the numbers out by myself. And for using the NPR command, I'll use the example of the 8 Olympic swimmers, and we gave out 3 medals. I will type in 8, math, probability, NPR. So 8 NPR 3. It's going to read this and do exactly what we did for that Olympic swimmers problem. Gave me 336. And then for that last permutation example, where I had 12, math, probability menu, NPR 4, giving 4 prizes to 12 people who entered a raffle, that still gave us 11,880, which is what we were expecting.